Okay, continuing on. We just found out the y component and the x component of the vector. We found that, of the velocity. So we found that the y component was 13 meters per second. I'm going to put the long version just so we have it handy here. Okay, so I have the y and x component. So now it's asking how high it will go. So we've kicked the ball. It's come here. So if we're looking at how high, we're really looking at vertical. Okay, when we're looking at vertical, a couple things that we need to know. At that maximum height, when you kick the ball, at that maximum height, my final velocity is going to be 0. It's going to stop. Okay, and my initial velocity in the vertical component is that 12.855. That's its velocity in the vertical component. The other thing that we know is we know that there is acceleration, and that is due to gravity, meters per second squared. What we're trying to find out is displacement. So we need to find a formula that has v final, v initial, acceleration, and displacement. So let's look at our formula sheet. Final, initial, this one has initial and time. This one has initial and final and time. We don't know time. Here we go again. This formula is what we're going to use. Okay, so the formula I'm using is v final squared equals v initial squared plus 2 times acceleration times displacement. I want to get displacement by itself. I'm going to subtract v initial, and then I'm going to divide both sides by 2 times the acceleration. So v final squared minus v initial squared over 2a equals just my displacement. Subbing in the values that I know. V final, we said, is 0. So I have 0 meters per second squared minus 12.85, that junk, 12.85575,219 meters per second, all squared. Important that you square it and then apply this negative sign, not square the negative. That will affect our answer. 2 times my acceleration due to gravity. Okay, this will give me my displacement. Let's look at my units here. I'm going to have meters squared per second squared divided by meters per second squared. So meters squared per second squared divided by meters per second squared. When you divide by a fraction, you're really multiplying by the reciprocal. So I have meters squared over second squared times second squared over meters squared. Well, my second squared cancel out. Meters squared divided by meters is going to leave me with just meters. So my unit is in meters. That makes sense since it's a displacement. So now it's just calculator work. 12, so you have to go this number squared, negative, divided by 2 times negative 9.8. Make sure even you put an extra set of brackets. A lot of kids will mess up on this double that we're still dividing by 9.8. Okay, so pause, get your calculator, make sure you can get this correct so when it comes time to a test, you know what you're doing. Okay, how many significant digits? Some of you might say, oh look, I have 3. No, my original equation where I got this vertical and horizontal component, I only had 2 significant digits. So my answer can only have 2 significant digits. So 8.4 meters. So the question was how high it will go? 8.4 meters. That makes sense when you kick a soccer ball. at almost 45 degrees, yeah, 20 meters per second, that seems reasonable. It's not like we got 700 meters. That would not be reasonable.